So today we're talking about the graphs of rational functions, and on this screen you see the graph of the rational parent function. Let's talk a little bit about it. I'm just going to pick a couple of points here and see where they would be on the graph. Alright, so I've completed a little table over here. When x is negative 5, f of x is equal to 1 over negative 5. So that's negative 2/10, right there, right? When x is negative 2, f of x is equal to negative 1 over 2, or negative 1/2. That's negative 5/10. So that point's right there. And then when x is equal to negative 1, y is also equal to negative 1. And so on. Now at 0, it's undefined, because 1 divided by 0 is undefined. You cannot divide any number by 0. And then moving on, as we get into values greater than 0, when x is 1, y is 1, because 1 divided by 1 is 1. When x is 2, y is 1/2, because 1 divided by 2 is 1/2. And when x is 5, y is 1/5 or 2/10, because 1 divided by 5 is 0.2. And so that's how we get all of our values on here. So let's talk about asymptotes. Well, we already identified a vertical asymptote here. We said that x can never equal 0. And you can also see that the graph has a horizontal asymptote at the x-axis. So both the y-axis and the x-axis here are asymptotes. So we have a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. We do not have x or y intercepts in this case. So there are no intercepts, no x or y intercepts. In the end behavior, well, as x approaches infinity, so as we go to the right, y approaches 0. And the same thing happens as we go to the left. As x approaches negative infinity, f of x once again approaches 0. All right, so that is an introduction to the rational parent function. Let's see what happens if we change it up a little bit. So now on the left, I have the parent function, and we just talked about that one, right? And then on the right, I've changed it a little bit. Here I'm subtracting 3 from the function. And how do you see it changing? What changed here? It may help to put a little dot at 1, 1 on this graph. When I look at the at x equals 1 on the graph on the right, I see that it's now at negative 2. That's just kind of a reference point for comparison. So what happened here? Well, my graph shifted down. It translated down 3 units. Let's look at another one. Okay, so here I have, again, my parent function, and I'm going to look at that reference point. That's a nice clear one to look at. And then when I find a comparable point on my other graph, I see that that's 1, 4. So what happened here? Well, this time we shifted up 3. And that kind of makes sense, doesn't it? We added 3, so we went up 3. And earlier, when we subtracted 3, we went down 3. So these are vertical translations. If we subtract k units from our function, we'll shift down k units. And if we add k units to our function, we'll shift up k units. Now take a look at these ones. They're not shifting up or down. How are they moving? They have moved to the right. So our second graph here, by subtracting 3, we went 3 units to the right. It might seem counterintuitive that subtracting moves it right, but that's what happens. All right, and over here, our graph has done just the opposite, hasn't it? This time, instead of shifting 3 to the right, we've shifted 3 to the left. So when we add 3, we go 3 to the left. Okay, so for our horizontal translations, if we subtract k from the denominator, then it's going to go k units to the right. And if we add k units to the denominator, it'll go k units to the left. So at the bottom of the screen here, I just want to draw your attention to the difference between these two. So on our first set of graphs, we looked at what happens when we add k to the entire function, like this. And we said that's going to go up. Now if we add k to the denominator, see how it's in a different location? That's when it goes left. So pay careful attention to where your k is located to determine whether you have a horizontal or vertical translation. Now what's happening here, we may have to pay close attention to see. So in this case, what's happened is we have vertically compressed this graph. So I want you to imagine some arrows pushing in like that. It's like we squeezed this graph closer to the origin. So when we multiplied by a value between 0 and 1, we kind of squished our graph, we compressed it. What would happen if we multiplied by a value greater than 1? So 3, for example. So in this case, we have vertically stretched our graph. So I want you to imagine arrows kind of pulling out like this. So they're stretching the graph out. So vertical stretches and compressions. If we multiply by a factor of 1 over k, that's going to compress our graph vertically by a factor of k. And if we multiply the graph by k, that's going to vertically stretch the graph by a factor of k.